Hello everyone. I am Dr. V. Sita Lakshmi, Professor, Department of ECE, KPR Institute of Engineering and Technology. I am going to explain you about the addressing modes of 8086. So addressing modes are the techniques used by the CPU to identify the location of the operands needed for executing an instruction. They provide rule for interpreting the address field in an instruction, helping the CPU fetch operands correctly. So opcode tells the CPU what operation is to perform. Example, add, move, multiply, MUL, DIV, all those things are called opcode. An operand is nothing but a data or addresses on which the operation is performed. There are 9 different addressing modes in 8086. Immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, indexed addressing mode, based index addressing mode, based indexed addressing mode, based and indexed with the displacement addressing mode, string addressing mode. Immediate addressing mode means the data is given immediately in the instruction itself. For example, move AX, 10AB. 10AB is nothing but the data that is moved to the AX register. And in this, AB is moved to the AL register, 10 is moved to the AH register. Register addressing mode. Here, the data 10B is placed in the BX register, and we are using the instruction move AX, BX. Content of BX, that is 10AB, is moved to the AX register. So, suppose if you want to move 8-bit data that is placed in the BX register, move AL, BH means content of BH is moved to the AL register. Direct addressing mode. So memory address is given directly in the instruction itself. For example, move AH, in bracket 1000. 1000 is nothing but the memory address. So this bracket indicates that 1000 is memory address. If bracket is not there, this 1000 indicates a direct data. And then that addressing mode is called as immediate addressing mode. Since this is a direct addressing mode, in order to represent a memory, bracket is given, which indicates that 1000 memory address is having some data. That data is moved to the AH register. And here AX register is given, which is 16-bit. So content of 1000 and 1000 plus 1 is moved to the AX register. Register indirect addressing mode. So here memory address is given indirectly in a register. For example, the 1000 is placed in the SI register, and this bracket indicates that the content of SI is nothing but memory address. So the content of that data and 1000 and 1000 plus 1 is moved to the AX register. Indexed addressing mode. Here we use index registers like SI and DI. For example, move AX, SI. In the content of SI and SI plus 1 is moved to the AX register. The content of next instruction jump DI. The content of DI and DI plus 1 is moved to the IP register, that is instruction pointer, and the instruction jumps to that particular address. Based addressing mode. Here base registers like BP and BX are used. So for example, move AX, BP. That means the content of BP and BP plus 1 is moved to the AX register. The content of BX and BX plus 1 is moved to the IP register, and the instruction jumps to this particular address. Based and indexed addressing mode. Here both base registers and SI registers are used. So the content of BX is added with SI. If you are adding this one, you will get one memory address. The content of that memory address and the next address is moved to the AX register. Here either you can use BX or BP. The content of BX and DA are getting added, and that content and the next content is moved to the IP register, and instruction jumps to this particular address. Based and indexed with the displacement. Displacement is nothing but one number. For example, move AX, BX plus SI plus 6. 6 is nothing but a displacement. This is a BX is a base register. Either we can use BX or BP, or SI is the index register. We can use either SI or DI, and 6 is the displacement. The content of BX is added with the SI, and both are getting added with the number 6. So if you're adding all those things, you will get a memory address. The content of that address and the next address is moved to the AX register. Similarly, in the content of BX and content of DA is added, and this is added with the 6 and the resultant content, and the next content is moved to the IP register, and the instruction jumps to this particular instruction address stored in the IP register. Increment BP plus SI plus 5, that is content of BP is getting added with the SI, and for displacement 5 is added with that. Altogether we get one memory address. The content of that memory address is getting incremented. Similarly, in the content of BP plus DA plus 5, we will get a memory address. In that memory address, some content is there. That content is getting decremented. DEC means decremented. String addressing mode. So here string is nothing but a series of data. Source string is always placed in the source index register, and its starting address is given by the data segment, and destination register destination string is stored in the DA register, and starting address of the segment is given by extra segment. So move source byte, that is 8-bit data, series of 8-bit data is moved from source index register to the destination index register. Here direction flag plays very important role. If direction flag is 0, the strings are accessed in ascending order. That is, string available in SI, SI plus 1, SI plus 2, SI plus 3 is moved to DA, DA plus 1, DA plus 2. If direction flag is 1 with descending order, that means string available in SI, SI minus 1, SI minus 2 is moved to DA, DA minus 1, DA minus 2, etc. So with this, addressing modes of 8086 is over. Thank you.